So, welcome to developers meeting on December the 4th, right? Yeah, today. Yippee! Merry Christmas to anyone. So,
Merry Christmas or holiday of your choice.
thank you, Santa
Because
Claus.
Rosh Hashanah's coming up. Rosh Hashanah's coming up. Hanukkah, and so on. There's a whole lot of groups, religions and other. They all seem to have some kind of thing going on the winter solstice. Again, another amazing coincidence, I guess. So,
Okay.
Anyway, whatever your faith is and whatever it is you celebrate at this time of the year, go for it. And I do wish you all well.
Thank you, Santa. So, yeah. Okay. Alright, so many things on my list today. Where shall I start? Anything you want to start? Any one of you want to start with the topic? Otherwise, I run through my list. Silence it was. Okay, so I'll start over. But don't blame me. I asked you before. So the big question, like the elephant in the room, is the alpha version. And yes, I think it is my duty to once in a month to come back to the question, where are we? So
oh no,
maybe anyone of you. Oh no, I don't know where Santa is. But I want to know where all of you are. So maybe just after each other, maybe you say where you are or what. No, I want to put it different this time. Can you, from your point of view, say what is missing for the alpha, as we call it? And let's start with IDO, because let's do it top down in a technical way.
Yeah, I'm actually going to focus on this week. I need to get the camera working, still then get it to work.
All right. What is the problem you're facing?
I'm not sure, but it's either permission or some kernel module that is missing. I need to look into that. I was focusing on my license, and I got sick this morning, so...
Oh, yeah, first of all, congratulations to your license.
Yeah, thanks.
You nerd. 35 out of 35 points. Well done.
Yeah, how easy was that test?
It's easy, it's not hard.
Is it like your driver's license deal where you get to see an animation and you pick A or B?
It's simpler than that. It's like
oh,
it's like
is it an open book test too?
No. It's actually not open book. You're not allowed to use calculators that have formulas in them. But there is a bit of electricity, like Ohm's law, recognition of some components. That's not hard, but then it's like the rules of the FCC on how to transmit and when, bands and stuff like that. But if you read it and practice a few times, then it's not that hard.
Do they have a practice test?
Oh yeah. I can send you an app it will train your brain to memorize all the answers for all of the levels. So I did the technician. I will do also the general and the extra in the next coming, I guess, month.
Cool.
Yeah.
All right. So first of all, welcome, Rebecca.
So anyway, for the camera, I first need to get it to work.
Hi, Rebecca. Sorry. First of all, let's welcome Rebecca. Okay.
Oh, hi, Rebecca. Yeah. and once.
Okay, Ido. Sorry. Go ahead.
Yeah, and once I get the camera working, I'll just need to create that SD image to make sure that it's running properly and configured with the Indy. And once it's all done, then I will go ahead to the ROS2 and just move, read from the Indy server and write to ROS2. So it shouldn't be too hard.
Okay. So
Yeah.
Christian is not here today, but as far as I know, he's also busy with the driver and the kernel, right?
Yeah, so he's working on the next step actually, like implementing with his library everything in Rust.
Ah, okay. In Rust,
Um,
okay.
Yeah. So by the time I get the SD image probably working with everything, I should be able to use his and then just integrate it with ROS. And I shared that I found like a ROS 2 kind of Nix implementation that will allow to start everything as services just by configuration. So that's something that I will use soon. Yeah.
Okay, so
And on my task is actually to look at the Docker first.
yeah.
I just didn't have time this week. And last night I passed out. I felt like really, really weak. So didn't get a chance. I wanted to do it last night after the test, but I didn't feel right.
Yeah, okay. First of all, get better soon.
Yeah,
Is it
that's the plan.
you got the flu or something?
No, I don't know. Like sometimes I get like this weakness. I'm just getting tired.
Did you had COVID once?
Long COVID, yeah. You can
Oh,
call it long COVID symptoms.
oh
Yeah.
dear. Okay.
Well, hope you don't come on down with the long version of it. I'm still getting over it, and my COVID actual was over a year ago,
Oh dear.
and it sucks.
Oh yeah.
You have my sympathy.
I
If
had
that's
a
what it
heart
is.
attack. I had a heart attack from it, and I'm still recovering. So.
What?
Yeah, I had a heart attack a year and a half ago after I got the COVID. Yeah.
After you okay.
Yeah, like two months after. Yeah.
Wait, you mean the vaccine? You got the
No,
vaccine.
I got the vaccine after. Yeah, before.
I thought you got the heart attack after you got the vaccine.
No. Before. I had COVID.
Huh.
I lost sense of taste and smell. Yeah, and then I got heart attack.
Jesus.
And just so you know, like 4 months before I got sick with the COVID, I did a hike of 10 miles, like in the mountains, Colorado. So I was in good shape. Yeah.
Oh, yeah. Okay. Let's start this on another session, not on record.
Yeah.
I don't think it's
Yeah.
suitable
Yeah,
here.
probably
Okay.
better.
Yeah, you do have my sympathy.
Get better soon.
Thank you.
Okay, so if I come back to the topic you've spoken, so the final goal is from you and Christian. Let's say both of your work is to have that stream provided as a ROS2 node.
Yes.
Okay, so the next part will be to now. I mean, the next part is already more or less done. As Mike, please correct me if I'm wrong, but you already have a ROS2 version of your tracker, right? Mike, you there?
Sorry,
Oh, yeah.
yeah, I was just on mute. Yeah, yes, there's a ROS2 version. It doesn't, it currently doesn't like store any tracks or anything like that. So, but that's something we can look to implement. So that, yeah.
Okay, but it can.
Sorry.
Oliver, sorry, your microphone is producing noises.
Can you hear me?
Yes, but we also can hear your background noises. Okay, back to you, Mike. So my question is your tracker what you said just right now? Does this mean that it could be easily done to connect your ROS, your tracker part? No, wrong wording. So let your tracker part subscribe to the data stream from the camera?
Yes, that shouldn't be a problem.
Okay.
Yeah, so that shouldn't. I don't really foresee that to be a problem at all.
And
yeah, we will broadcast the same the same topic that you're listening to now, so it should be fine.
Yeah, I mean that stuff's quite easy to remap as well. In all fairness,
Yeah.
So it's a so that's really not a problem as long as we just agree on message types close to the time. That's fine.
Yeah. Yeah, we
Yes,
will
that's
transform
fine.
it to make sure that everything is working, to the to like a proper quality that you can process. And later on, we will work on the 16-bit, kind of more advanced stuff.
Yeah, no, that's fine.
Yeah.
No worries.
Okay, cool. So I think there was a discussion last week, and where it was not clear, at least for me, that I was asking, is the stream that the camera then provide a frame-wise, or is it encoded into a video stream?
Okay, so we will broadcast frame by frame.
Okay, frame-wise, perfect.
Yes, the only thing that will get a stream of video, like a encoded video, will be the user interface.
Ah, yeah. But it does not come from the camera, so the encoding
No,
is
it's
done
not
somewhere
coming
else.
from the. It's not coming from the camera.
Yeah.
Yeah, it will
Doesn't-
come later on.
Doesn't make sense.
We'll figure out who
Yeah.
exactly processes it. Yeah.
I think we have spoken about it. I think that a dedicated Pi, or one of these Pis that does, for example, the master control program also provides a sandbox for the web services. And so, yeah, okay. Anyway.
Yeah, but we will broadcast a compressed image, like a lossless compressed image.
Yeah. So and Mike, your tracker is working frame-wise anyways, so there's, I think, a seamless interaction, right?
Yeah, so there's a fairly standard way to transfer frames around a ROS network. So and I use that standard way, so that I should just be able to subscribe to the topic, and it should be able to process the sequential images. So that shouldn't be a problem.
Perfect. All right. A question to Ido. So the whole ROS communication is sending UDP signals. What if the packages, the UDP packages, do not come aligned in? You know what I mean? Time-wise aligned in. What if some packages are quicker than others?
Yeah. So two things. Number one, because the system is isolated, the chance that will happen is very, very low.
Mm-hmm.
But that's also a configuration of quality of service on the router that we will choose, right?
Yeah. Okay.
On the switch.
To give priority, for example. Okay.
Yes. So we will have to address that if we start seeing that happening. Yeah.
Yeah. So essentially, you can set it to say it has to deliver a package, and then it will retry. So if the contract between the nodes are, I can't remember the actual name, but if it's like reliable, I think it's called reliable.
Yes.
If the communication contract is reliable, then UDP will continuously try until it gets an acknowledgement that the other nodes received the data. So I wouldn't worry too much about missed deliveries and all those sorts of things.
Yeah, it's just Mike. So a bit of that on that. Okay. You don't want to set up reliability on the video stream.
No,
because,
I know.
because that's something that doesn't require reliability, right?
Yeah, no, I'm not saying we will. I'm just trying to address Richard's question.
Yeah.
If you're in a position where you expect reliable communication, but UDP by its nature isn't, I'm just trying to say that you can specify it to almost be reliable.
Yeah. So it's now that I'm a technician licensee, I can speak a bit about RF. but you have the same problem with RF, right? There are protocols that will have error correction, like the digital protocols, right? But they come with a cost, right?
Yeah, of course.
That they need to provide a checksum and validity and then retries in case of a failure, right? So ROS has this capability, but you don't turn it on for like a stream of images because, if you lost an image, that's fine, right? As long as you're not losing like seconds of it, right?
I think the loss of an
Yeah, so
image is less troublesome as a wrong order. It would certainly
so
mess
I
with the
could
tracker.
probably
So if you lose it and you get something that is older, then first of all, ROS will not let that happen.
Ah,
Okay.
okay.
Like you don't like if you got something newer and then something older comes in, ROS will not let you process that.
Ah, okay.
Okay, like ordering is crucial, right?
Okay.
Now when you have reliability, that's usually when you want to look at history of events, not just one.
Yeah.
So ROS will actually keep that in kind of like cache memory local to the process, okay? And it will do all the reliability and retry in the background for the process, so you don't really aware of it. But when you get the new image, you also get like the new message. You will also get like the last history of it. Okay, so you can see the changes.
Okay. Yeah.
Okay.
Okay. So it's logging the history of it, not the data itself.
It's keeping the history of the last
Yeah. Okay.
few messages. You can say that keep the history for seconds or whatever.
Okay.
There are different ways to achieve it. Yeah.
Okay. Got it. Yeah, it's better to drop an image than to have a wrong order. Absolutely.
Yeah. But again, lower level speaking, if we see loss of messages like a lot or whatever, that's usually mean that the network is not properly configured. So that's something on the layer 2 of the switch.
Meaning we
Okay.
need managed switch.
Yeah, that probably will be a good idea. A managed switch for like layer 2 that we can configure the multicast groups. That's probably would be the best.
Yeah.
Yeah.
But you can't do this on normal switches. Okay. Yeah, or we take the standard
but
MTU.
again, Richard, there will not be a lot for us, and the network is isolated. So the chances that you're going to lose messages are very, very low because the components are very close to each other.
Yeah. No, I absolutely with you. So as long as the strategy is to drop, the tactic is to drop instead of having a wrong order, because it's obvious that a wrong order will certainly mess the tracker.
That will not happen.
That will not happen. Perfect.
Yes. that will not happen.
By the way, welcome Fabio, Lionel, and Matti. Hi guys. And there he goes.
Hey guys. Hello.
Hi Matti. Hi Fabio. Okay. So so the next thing is, and Mike, I think you are on it right now, is to have the tracker put out the track with all its content, the vectors and the cropped images, and then you at that point try to put it into an inference machine, right?
Yeah, so yes. So I'm looking into so that's quite a yes, so I'm looking into that. It's quite a big area. It's quite a large area really. So I've narrowed it down to a couple of options, and I have actually logged the issue on one of the repos because there seems to be some severe overlap between several of these node packages, and I'm trying to understand which is the better one to use. If you want me to go into a bit of detail, I can, but so yeah, so I'm exploring that at the moment. I did actually, oh, I did actually get the so okay, sorry. So,
Take your time.
yeah, no, I was thinking maybe I can go into a bit more detail once you've covered the alpha if you want, because otherwise I might just
Yeah, it's
get carried away.
yeah, true, yeah, true. So the other part from the output of the tracker is the kinematics. So let's say only the vectors, the event data that is then classified. And Lionel and Yannick, you both work on the same thing.
Yeah. So I've been busy this week studying ROS. So I'm following a long course starting with ROS 1, and then I'll make the switch to ROS 2. But I'm learning from the start all there is to know about ROS. And it's a great system, I must say. I'm very enthusiastic to be working on that. And so all these built-in packages that there are, I think it's going to make our life simple. Like I seen there was a Teensy package to drive the servos later on.
Yeah,
Anybody familiar with that?
yeah.
And yeah, so I think that's definitely the platform. The platform is going to be great. It's going to be simple for everyone to develop their part. And so I'm not haven't started developing yet. I'm still working. I'm still just learning the platform for the last week, and I hope to start implementing. So first the classifier, then the neural network for the kinematics. So that's but it's just module you can implement. I think that you can implement whatever code you want in those modules, and yeah, it's fun stuff. Fun stuff. Thank you for that.
Yannick, you want to contribute anything?
Yeah, so today I shared the scripts that I presented 2 weeks ago. So I uploaded it on GitHub on the in the kinematics repository. So if anyone wants to look at it, he or she can now. And what I haven't uploaded yet is the script that generates training data for model training. So I'm currently just working on making that readable, let's say, and easier to apply. And I haven't finished that, but you can already use the trained model that I've presented 2 weeks ago. And what I also did today is I checked, and Richard, you proposed that I should check how long the tracks actually are that we have. So I wrote a script today that characterizes the length of the tracks, and I can quickly, if you're interested, I can quickly show
Share.
you.
Absolutely.
Okay, how that looks like currently. So, I'm just gonna share my whole screen, I guess. So, I think you see now the result of it.
Expectable, yeah.
So, yeah, it's pretty much like how we expected it, I guess. So it's not the result for all the videos that are in the Google Drive yet. So it's just for this, let's say, curated list that I have here in this sort of database, and I use that to look into how long all of the tracks in all of these videos are. And so it's about half of the tracks are smaller than 25 frames. And I think that's good to know for basically framing how fast we want to make a prediction, right? Based on anything, really. So I currently make a prediction based on 30 frames. But when you look at this distribution, you would say rather it would be better to aim for 25 or 10 frames
10
rather.
frames, yeah.
If that would be, that would be much better. Then we would probably still wouldn't be able to categorize like 25% of the tracks. But for the rest, we would have enough time to make a prediction what it could be. So, and
Yannick, would it make sense? I mean, this is now a fixed version with a fixed number of frames. To make that variable, so let's say to say you start estimating a track when the first 10 frames are in, and then the next frame is an 11, a 12, a third, and so on. Would that be possible?
Yeah, with the model that I use right now, it doesn't seem to be possible, but I know that there's an own class basically of models that are suited for that task or specifically designed for that task to make a prediction as soon as possible. And these models decide that on their own basically when they are when they collected enough frames to make a prediction. But I haven't found a Python module or something like that for these class of models yet. So that seems to be like an active field of research, and it's kind of new, I think. So yeah, it's gonna be difficult. So what I would try at first is how to check how reliable the model is when we just feed in like 10 frames and check how good the accuracy of the model is when we do that. So I haven't done that yet, but I hope that I eventually can do that next Sunday.
Okay, cool, great.
Yeah.
Can you give an estimate of the performance? Let's say you said 30 frames were the package size. So how long does it take on whatever CPU you're running it?
Maybe we can just go back to the presentation 2 weeks ago. So I've shown you how long it takes. It takes maybe 2 seconds or so for the prediction. So we have to. That's a crucial point. So we have to make that faster, basically.
Okay, yeah.
That was the conclusion of it.
Yeah.
Yeah. So anyone who's able to take a look at this package, let's recheck how that package is called. It's called SK Time. Where is it? It's called SK Time. Here it is. And this is the algorithm that I use right now, Hive Code V2. And if anyone can make this one faster, that would be great. So currently, I would say it's too slow.
Okay.
To be used in a production version.
And the ability to do it also in increasing chunks of packages coming in. So you start with 10, 11, 12,
I would think so. Yeah.
That would be nice to have.
I would think so.
So let's say that it cycles per incoming frame.
Yeah, I think that would be complete overload, I guess.
Yeah.
Because even the current version that I have right now that just does it on 30 frames is needs too much time. Yeah.
Fabio, wouldn't that be a topic for you?
That's what I'm hoping.
Yeah, I thought so. Either he is not listening or he's not snapping it. There's a lure.
Yeah.
Hey Fabio, you're very silent. Can you turn on a bit higher your mic?
Let me see.
I couldn't understand that.
Is it better now?
Yeah, much
Yes.
better. Thank you.
Okay. It was with the wrong mic here. Okay, hey guys.
Hi.
Yeah. Sure. I can give it a try and see how it's coded and see if I can just make some things to make it run faster. I can try it, of course.
Dude.
Yeah, that would be awesome. So it's a Python package and it's on GitHub, so would be great.
Yeah, can you send me the name,
The link,
written name, so
the GitHub
I'll
link.
try to look at it later.
Yeah, I'll send you a link.
Okay, perfect.
Thanks.
Cool.
No problem.
Yeah, Fabio, do your magic.
Exactly. So I think that was it basically. And I'm gonna stop sharing my screen.
All right. Thanks, Yannick.
Okay. Yeah, welcome.
So my question, I know my basic question was about the alpha version and what's it going to be. The last two topics, just for the record, are not part of the alpha. So we are not inferring and not doing classification in the alpha. So the alpha will be purely taking the stream from the camera, doing the tracking and putting out events and storing that to a local file system, to a NAS attached file system. Right? Ido, you agree or am I off?
So sorry, my son is here. Can you repeat the question?
No, I was just, am I off or am I right?
About what?
You didn't hear the last one. Okay. Now
No.
I want to come back to the question, to the initial one about the current status of the alpha, or better, what is needed and still missing until we call it the alpha. Okay.
Oh.
So I want to just come back because the last two parts were not part of the alpha. So the kinematics estimation and the inference with the images will not be part of the alpha. So we concentrate purely on the data stream from the camera until it goes to the tracker and finally stores images, frames, videos, what have you, and then putting it out on the user interface, right?
Yeah.
So that's basically the alpha as we call it, right? Okay.
Yeah.
So just for the record, I said that so that just to give not the wrong expectation, So these two inferences and classification will be in the next version. Yeah, that's so. Considering the one part that's still missing, it's the one part that is a kind of a control program that has also a sandbox with a web service and so forth, which then delivers data as a ROS node. I think is it is designed right now, not as a web service. Is it true or am I wrong?
Okay. So if you speak about UI will have both, right?
All right.
It will have both like a normal backend to serve all the HTML and whatnot, and then the ROS2 side for the real-time data.
For the streams.
Right.
Okay. Got it.
Yeah.
So the style, the design, the front end is web service based, but the content, the stream is ROS2 based. Okay.
Yeah.
So this part is still to be done because we need the UI in let's say to call it an alpha. Okay.
Mm-hmm.
Which brings me to Rebecca. Maybe Rebecca, you can say from your point of view what is still missing for what we would call the alpha. Rebecca, are you there? did we lose you? Rebecca, Texas. Hey Tommy, can you look around the corner? What's up with Rebecca? Okay.
She's further south than
Ah,
Ido
there she
is.
is. There she is.
Sorry, my cell phone was frozen for a minute there, but I could hear what you were saying.
Okay.
You wanted to know what we need for the alpha version, or what's still
Yeah. What's
required
your
for the alpha version?
exactly your point of view?
Okay, for the alpha version, basically we just need to finish up the camera, the media player, I would say,
Yeah.
for both the simply for the fisheye view of the camera, since we don't have the other portion, the other camera ready just yet.
Yeah.
So I would say that's all that's needed. I'm currently working on the GUI connection between ROS2 and the GUI. I had it working previously on my other computer, and then I tried it on my PC this morning, and for some reason it's not working, because you actually have to manually change some of the code inside of the ROS-Bridge server package. Yeah, so I have to go back and get what I have on my other smaller computer and transfer it over to my PC, because there are some things that you have to change in a Python file and a couple of other places. So once that is done, then all we really need to do is work on getting the camera to display or render the stream in the GUI.
Yeah, that's my plan for this week.
Mm-hmm.
Cool.
And I think that's going to include a package that was mentioned previously, I think in the last meeting by Mike. I think he found a camera player through the ROS-Bridge, or through ROS actually, that we can use. So,
okay.
So I think that's what our status is right now.
Okay, perfect. Thank you.
Cool.
Okay. Yeah, I'm not talking about hardware right now because we all want to know. But yeah, okay.
Yeah, my cell phone is still stuck here. So I hope I answered your question properly.
Yes, absolutely. I do know where you are, because you write to us. My question was more for the record, so that we hear with your voice where we are right now. It's
okay.
Just for the YouTube record. Yeah.
Yeah. Oh, for the record, I wanted to add that I had, two different PCs communicating with each other via ROS2 over a network.
Mhm.
So that's accomplished.
Mhm.
My next goal was to get one PC to communicate to the other PC and show that information on the GUI, just like it would be if it were the actual Sky 360 station communicating to someone's PC at their home.
Mhm. Cool.
So yeah.
I saw this with the Hello World kind of tests you did. Yeah. Perfect. All right. Thank you.
And I think also,
Okay.
just one more thing, I was going to simulate an API, probably the WhipMotion API, with mock data, and have that run through ROS2 and have it displayed on the GUI as well. So that was my next step after what I'm currently doing.
Okay, great. Do you have data sets from the WhipMotion?
Well, I'm just simulating data, so yeah, I'm using what's needed, the data sets. Yeah.
Okay, perfect.
And that's all.
Thank you. So yeah, I consider this question now as answered. Any contributions? Anyone wants to add something? Okay.
Just one thing. Once I'm done with once I get the camera to work and broadcast on ROS2, the next step for me will be to do the packaging. So we have an image.
When you
That's
say
the image.
packaging, what do you exactly mean with packaging? I think you're already delivering frame-wise. What do you mean with
I'm packaging. I mean deployment. How you're going to install it on your station?
This package. Sorry, this was too close to each other. This okay.
Yeah, the SD image.
The SD image,
card.
the NixOS, the Nixing. Okay.
Yes, exactly.
Perfect.
Yeah. Hopefully we'll get it before the weekend. We'll have a nice kind of gift for people to download. It'll be a good start.
That would be cool. At least before Christmas.
Yeah.
My question to you was before Ido about a schematic. I heard it today in Mike something along that line about talking about message types. Would it make sense? I was talking about the a kind of a schematic about the ROS2 protocol and message types we're using to have an overview. Yeah, go ahead.
Yeah, I kind of showed it before, but if you remember when I demoed, I can demo it right now, but when I demoed ROS2 and I showed you the diagram of all the topics and all the parts that are running, right? So you get that schematic all the time, right? It's generated automatically from the robotic kind of environment, from the ROS environment, right? So what we will need to do really is when all the components are running, take a snapshot of it, and that will be it for the documentation, right?
Yes, that would be my next question. Would it make sense to have even if it's preliminary, a snapshot and put it on GitHub so that everyone gets an idea?
So Mike will have his snapshot right now. That will be like what you have. As soon as I'm done with my part, which will the I mean, you can get it from Mike right now because he's using a camera, or a video feed. So Mike, can you like take a snapshot of it from the ROS2?
Sorry guys, just run. I was trying to get something up so I could demo for you guys, so I wasn't paying attention before. A snapshot of what?
So you know when you run ROS2, you run that. Yes, now my memory is impact. There is that program that can show you all the topics that are running. It can show you the video of what's there, of the images.
Yeah, I've not. So I've
QRT, that's the name.
Yeah, so I've not really got back to actually running the Docker. So, but you can query the ROS2 commands to see what sort of actions are available and what the endpoints look like and those sorts of things. So when you say snapshot, do you mean snapshot of like the URLs or the?
No, you should have QRT on your machine, okay? Type like QRT, enter, and or try to run it. There will be like a user interface, okay?
Yeah.
Over there is a way to see the schematics of the system.
Okay, yeah, I know what you're referring to.
So it will show you all the nodes that are running, all the topics if you want.
So I guess so basically I put together a couple of README files which contains the topics that I published to and the message types that I published to those topics. So I do have that. However, my view is that when I converted Simple Tracker to use ROS, I created my own message types. Although
that's fine. That's fine.
Yeah. So I probably wouldn't advise to do that now. That's why I want to try and move away from that. But I do have all of that sort of stuff written up in a README that anyone can access. It's actually in the repository. So so if you guys are looking for essentially a bunch of endpoints and the message types that are published on those endpoints, that's fine. That's not a problem at all.
Yeah, no. So I was looking more for the diagram, the schematics.
Oh, okay. Yeah, no, I don't have one of them, and I can try and produce that. That's
Okay,
not a problem.
it should be very easy. Like it's really through RQT and that take a snapshot of it. So
Yeah, so no, that's absolutely fine.
okay.
I'm not entirely sure if RQT works in the dev Docker container that I do have. I don't know, but I can, if it is in there, then that's not a problem. I've just not used it in the past, so that's fine. That's not a problem.
Cool.
Cool. Hey, Mike, whenever you have the snapshot, is it then an image that we can put on GitHub, or would that make sense? In the README, for
Yeah,
example?
yeah, can do. I mean, so the only reason I'm kind of being a little bit hesitant about this sort of stuff at the moment is because it's really easy to map and remap URLs or endpoints. So that's a really trivial thing to do. And generally, I think it's quite it's a practice that's used. Like, for example, if you have a node that you don't want to have activated, you subscribe to an action that doesn't exist. And then if you want that node to be active, you remap at the point of launch to say, I'm remapping to the action that doesn't exist to an action that actually does exist. So the concept of remapping URLs is kind of baked into ROS and used quite heavily. So I don't want you to get too hung up on kind of endpoints and things like that, because they are really easy to swap in and swap out. That was kind of the point I was trying to get across earlier. I don't know if that makes sense.
Yeah.
I'm sorry if it doesn't.
No, so there are two ways to think about it, right? There is the development time when you will change URLs, and that will be highly customized because you change messages and everything. But there will be the deployment time, right? When you need to kind of fix it in time and space and say, okay, this is the version, right? So you know that it's reliable, right?
Sure.
Because the moment we start recording, we want reliability on that. So we want upgrades to work. We want to be able to go back and make sure that it's working. Every second that we are losing, recording time, it's crucial, right? That's how I like to think about it. So Richard, what I think will be the best,
I mean, if it's not needed, if it's not needed, I just thought if a newcomer wants to learn about what kind of message types are up and running.
So that was my question. If it's for development, then the best way to learn how the system behaves is by downloading the source code, running it, and then using RQT to kind of look at what the robot is doing.
Okay.
If it's for just documentation, then the recommendation for me will be we can probably generate it. Okay.
Yeah.
But it's probably not for alpha. But I can write a script that will run the two queries, figure out and create that schema.
Yeah, no. So for the documentation,
it's already there. The code is there. It's just using it.
Yeah. No, then it's not of any issue. I just thought that it's good to give newcomers, people who are thinking of whether they shall come in or should not come in, just to give them an idea of.
So as Mike said, it's already everything is there.
Okay, perfect.
So you just query the system and you learn.
Yeah, I get it.
Yeah,
I get it. Okay. Yeah, this you brought up the point documentation, Michael. So the idea is basically that you, Michael, put all the papers that already exist in a certain order and in a certain form.
Yes.
Yeah. Did you get all the papers yet? Did you have access to them and so forth?
I seem to have most of them. I've still got some problems reaching some of the repositories, so I want to put a link in there, and so you know where I'm at. And I do want to thank particularly Mike there, because one of the things that was going on with me, I was running in circles because I'm trying to figure out how do I do this on Linux, how do I do it on Windows, how do I make sure the Mac users can do it, and I'm used to having to do that. But since we said, okay, we're running just Linux, we're not going to support anything else, that was a huge one. What I'm doing is I'm building out a little matrix that says this is the core system, these are software packages, and where to find them, and all that kind of thing. So that's just a little block. And then that'll have the output going off like to the web page and to the build pages and that kind of thing. So, yes, I think I have access to most everything. And I'm not shy about asking if I run into something I have to have, but the biggest hang up has been between trying to support, too many platforms. And like I said, I'm not. I have access to the repositories. I think I have all I need, but I can't prove that as of the moment. Okay.
All right. Okay. I can send you a screenshot of all the repositories, and you can check whether you have access to all of them, or I have to go through every one of them. And but I had
just send me a list,
because there's. So today I was looking at GitHub because Yannick needed access for the repository kinematics, and I was checking from the GitHub root on the teams and the people, checking what access does Yannick have on the repositories. And I saw that on the kinematics there was readability, okay? But when I go into the repository of kinematics and go into the teams, I couldn't find Yannick. Why is that so? Is this a kind of a per default situation where everyone has at least read access?
Well, it's kind of the norm,
Yeah, it'll be a public repository, so everyone in the world will be able to view it.
Okay, so in this case,
should be able to view and read it, no problem.
You have to tell me what access you want to, because if you cannot read it, you don't know whether you see all repositories.
Yeah.
Idle.
Well,
any idea?
No.
Richard.
Yeah.
Oh, I was gonna say go. Yeah, Richard, just send me the list of the repositories you have, so I can confirm that yes, I can see them.
Yeah.
That for me would be like my next step.
Okay.
And then, like I said, from there, it's a matter of me, pairing off like the software for the tracker. Okay, it goes that points you here to Simple Tracker, and the back end system is basically essentially. Oh, that's a quick question. The Jetson Nano, which is the one I have, I don't have any of the better versions of it. When you go to do the download on it from NVIDIA, it automatically loads Ubuntu 20.04, I think is the version I got. Is that what we're going to run with, whatever it, shows up with? Or are we looking for a specific version of it?
So I'm planning to do. I'm planning to do the packaging. Okay. Mike, I don't know how you want to do the package, but if you want to do the same with me, that I can help put everything on Nix. It shouldn't be too much of a problem.
Okay.
But
all I need for the moment, all I really need is a list. Okay. This is what our build's going to look like, and then I can get that all broken out to everything I need it to to point to and associate it with, as far as getting, like I said, the documentation package rolling.
Okay, so let's do this, because I want to focus, okay? And I want to focus, and you guys tell me if you want me to focus on something else, that's fine.
No.
Right?
No.
Because in my head, like, I want to get the alpha done. So whatever is needed, I'll help with everything. Yeah. And what I'm missing is priorities, okay?
Yeah.
I can work on packaging, or I can work on camera, or I can work on whatever, right? What do you think is most important? Because we also spoke about that protocol last week about the ABSD, right?
Yeah.
Right?
Yeah. Well, my take on it would be just as a point of reference would probably be camera first, because then because basically as I get my little shell of here's how you do what, as I get that put together, then I need that information, but I don't really need it before. Okay.
Mm-hmm.
So that's not really that much of a problem. So I'd stay over on those kind of things for the moment. and worst case, I get farther behind than I already am. So, which I'm not worried about at this point. So, I keep thinking I got a little clear weather ahead that I can get a few things done in, and it keeps not materializing. But that's just life in the big city. So, anyway, so I would say stay on the camera side and that kind of thing. And if I get to where I got to have it, I can just DM you on it and say, hey, what's going on with this?
Yeah. Okay. Sounds good.
Okay.
Okay. Now,
Maybe give a different view.
as I said last week, the Nix image that I will create, we will generate 4 ARM, like Pi 4, and 4 x86-64. We will generate images. Okay.
Yeah.
Cool.
So the camera should work on both.
Can I
That was
maybe...
actually a requirement from the community. So.
Is that...
Mike, go ahead.
Yeah, no, I was going to say, could I maybe give a different view?
Go ahead.
So would it be worth trying to get the software out there and supporting any old camera, even if it's just a webcam, so we can get feedback on so we can just get feedback and show progress with regards to deliverables versus only releasing the software and supporting like a specific camera. Does that make sense? Just wondering if there's
Yes. So the initial camera of Sky 360, right? That's working with Video for Linux. So that will already be working with what you have.
Okay. So
Right?
okay.
So technically, I can work on actually packaging first, okay, and package you, right, with the Docker and everything under Nix, right, and we can have a version of the tracker working with the old camera, not the new one.
Yeah, I think it'll be just because there's going to be a certain amount of complexity with all this stuff trying to work together, and I think if we can just get it packaged and just working with a video, and then once we can get a package working with a video, we can package and see if we can integrate it with Video for Linux, so it just uses any old camera, and then I think then we can checkpoint and basically go, right, so this is the current feature set that we have. This is what it does. We know it can consume a video feed from a camera. We know it can consume video feed from a video. So now let's just kind of nail down what feature set we want from the application for alpha. We can then work on that, and then we can basically call it an alpha release sort of thing. Because there's stuff that I need to do in the ROS2 version of Simple Tracker as well. So currently, I run the nodes on. So I've got like a control loop in every node. I have to remove that so that it gets driven by the message that comes in and those sorts of things. So there's some stuff that I need to do as well to get all of that stuff working and okay. Also, so I guess the point I'm trying to make is that the Simple Tracker for ROS2 is not ready to go right at this point. There's still some additional work that needs doing and some refactoring and that sort of
But if I package like the nodes, right, and the runtime of ROS2, right, those are less likely to change. You might change the messages and stuff like that, but not really the nodes, right? Those are kind of more fixed.
Yeah. So when you say nodes, do you mean the packages, like the actual packages that make up the application? Yeah. So there are some changes that need to happen in every node currently because they run a control loop versus.
Yeah. No, but that's within the nodes. It's not outside.
Yes.
That's fine.
Oh, okay. So yes. So it's just So that's just. Yes. Okay. the structure won't
I will
change.
take in the end of the day your script that you're running, or you're running it based on the JSON schema, right, of ROS2, like all the packages and stuff like that, right?
Sorry.
So you have the
I've got a launch file.
I think I saw it. You have like
Yeah.
a packages JSON file or something like that.
Yeah. So it's a launch file. Yes.
Yeah. So I
Yes.
will take this and I will put it into Nix, and automatically what it will do, it will create services in the operating system running all of these nodes on boot.
Okay. Okay. Yeah. No. So with regards to that, I mean, we can try and do that ASAP because we can enable the kind of GUI that I've got. It's not. I know it's not Rebecca's GUI, but we can enable a GUI, and then
Yes. I mean, you can
Rebecca
run
can
QRT.
just.
You can run QRT and watch everything.
Okay.
Yeah.
Okay.
The system will be exposed, so that's fine. Okay, so yeah. So Richard, there is the other route, right?
Yeah.
It's starting preparing the SD image.
Yeah.
Right, for the tracker. Now, what's nice about it, first of all, it supports normal web cameras, right? And the old camera of Sky 360 is a normal kind of, the interface is the same. It's working on video for Linux.
Yeah.
Right? So that should be able to work. So that, so that's probably, I like it more.
And then there's yeah, sorry.
No, it's fine, because at least this I know what needs to be done with the camera. I'm still investigating why I can't recognize it. Right, it's still unknown. Still unknown. Here I know I need to create an SD image. It's probably like single command, and then it's just integrating what I posted on ROS2 channel, which is really like the Nix configuration, how to run all the nodes, and that's pretty much it. So it should be straightforward.
One thing that would be really cool to get into the alpha version as well is the performance improvements that Fabio's made on the background subtractor. So that would be really cool because that will make quite a difference to the amount of frames per second we can process. So I would definitely say that we should try and get that in there as well.
Okay. Okay, cool.
Okay. Shall we vote? Anyone against this idea? Anyone opposing this idea? So that's what you wanted to know from us, Ido. If we are all okay, if you
it's
the
not
camera
like
and go for the.
Yeah, it's about priority, right?
Yes,
like what
exactly.
to do.
Exactly.
Because I will get both of them done. It's just
but after each other. I know. I get this.
Okay, so I'll
are you okay with this change?
Me, yeah.
Yeah,
it's fine.
Really? Okay.
Yeah.
Okay, perfect.
It's not change, it's priority. Different.
So I guess, Mike, your motion is accepted.
Yeah, good.
Okay.
Thanks. That I think that's the first time I've ever had a motion accepted, so that's very formal. Thank you.
Perfect, and it is on record. Okay. Lionel is not there. Okay. Okay. Ido, you put forward a topic that you call APRS. Please enlighten us.
Yes. So this is a protocol. It's kind of nice. So I learned about this protocol again I learned about this protocol from my RF studies, and it looks like there is a protocol designed for exactly what Mr. Santa Claus here asked me about 2 months ago. if he has multiple stations, how they can communicate and share knowledge,
Yeah.
right? And this protocol is exactly designed for that, for RF. And there are a bunch of implementation for it in Rust, in other languages, from what I saw. But I was thinking that we can utilize it to be the output of the tracker. Like the same message types, because first of all, there is no. I didn't see implementation of ROS2 in this protocol yet, and so that is one thing that will be very nice to have. Even if we go further on with a plug, for communication between stations, that can be like over the internet, but at least we know how to share object tracks, detections with history. That message, that protocol defines it pretty really, very, very well. We're sending messages and all of that.
But the data that you are consuming here is only metadata about an event, but not the content. Let's say the terabytes of data, gigabytes of data.
No, it's not petabytes of data. Again, this is designed for, it's a very lightweight protocol.
Kilobyte packages, okay?
Yes, it's all about positioning, like where was the object detection, like the GPS location, right? What is the object size, what's the tracking of it? There are these metrics that defines all the properties, right? That's what I mean. It's the message attribute for a track, or what you can consider also as a target, right? So it will have some plots, maybe some tracking history, right? So the temperature, all of that is in this protocol.
Your idea is to have a central node somewhere, somehow, that consumes all the events of all stations worldwide, and then distributes the information via RF.
No.
Every station is sending. Okay, go ahead.
No, first of all, the protocol today on the RF is already exists, already working, and it's already being used by stations. When they do object detections in skies and whatever. Okay, the protocol designed for that.
Okay.
What I'm saying is to use the same thing internally in our station.
Yeah.
Okay, so the Sentinel, right, is producing these messages from the protocol. Make sense?
Okay. You receive what entity? Go ahead, Mike. My questions later. Go ahead, Mike.
Yeah, Richard. Let me give you a little fast background and where I wound up talking to him about it. What's going on, or where this whole thing started? A couple of weeks ago, I was in touch with a local observatory. Okay, and I wanted them to host one of these trackers. Okay, and the guy in charge there, he's all for it and everything, except because of the nature of their connection, he won't have he's probably not going to be able to give you an internet connect. He'll locate it, provide power, all that, but there's a problem getting, data back from the thing, basically. Now, I think I can resolve that with no other problem. But the backup plan became, okay, there's bound to be people like, radio amateurs around. So if I can go from the tracker location to one of those local, local amateur, okay, and then let them, put on the internet back to me or whatever, it's got to happen with it, then that would meet the case. All right. But the other thought out there, and again, this is me thinking, a bit farther ahead, because as I mentioned, I've done a lot of networking kind of things on a national level. And so it's one of those, if I've got, 10 trackers out here that are all out there on about, 30-kilometer spacing, and I want them to be able to talk to each other, and given the wide open spaces and things like that, it occurred to me getting that, data back from them might be a problem. Okay. And so what Snick came up with was he found this little amateur radio packet transmitter. All right. And so basically, the way I've looked at that, providing it's got the range, then it'd be a simple matter to, instead of say having this thing broadcast out on like a Wi-Fi or over the Ethernet on the device, then okay, I just reroute that to this little transmitter receiver and send it off to my local, whatever my local internet access point is, and receive that, be able to receive that data that way. And the other side of it, let's say I've got two of these out there in the middle of nowhere, and they know about each other, right? When one of them says, "Oh, I've got something on this vector," then the other one could say, "Oh, okay, let me take a look too." And the idea is, be working towards so that multiple trackers can triangulate if whatever the target is within their, within their visibility. So it's one of those, clever ideas to overcome a particular situation that, basically ran amok from there. So,
Okay. So it is a kind of a let's say a communication between stations that enables local stations that are in connection to exchange tracks and
exactly.
Yeah. So
why that
Exactly.
a
think
sentinel
about it.
then track. Yeah, go ahead.
Think about it as a situational awareness protocol. Okay, they're designed to give you the warnings, the alerts, the messages, if text messages, weather, objects that you recognize, anomalies that you saw, right?
But it's not about relaying data. It's not about a network. So propagating the same package from US to Australia. It's local. It's
well,
only emitting.
It's planned to be local. But it could do that if there was a need to do it. As originally envisioned, it was just a local.
Yeah, okay, but in a special case,
in this case, it's planned to be a local thing.
To Alaska, you have to make your intermediate transponder.
Richard, it doesn't have to be RF. Okay, RF has its own RF has its own peer-to-peer. Okay. The solutions are already there with repeaters and whatever. I can propagate a signal from anywhere to anywhere in the world. Okay, that they know how to do for a long time. Okay, we know how to do it on the internet also, right? Using peer-to-peer protocols or whatever, right? And normal server or the cloud. So, but that's not what I'm speaking of. What I'm speaking of is the protocol itself, the messages. If now Mike, is saying like I had my own messages, okay, but I want to, I want to use ROS2 messages, right? What is already there for tracking? There is no a standard, okay, for the tracking messages, like what we are tracking, where is it in the sky, okay, what is the health-wise of the system, right? Those are not defined anywhere. APRS has those defined for stations for RF purposes, but we can utilize the same thing for our purposes, regardless of RF.
When you say we utilize the same thing, are you talking about the protocol only, or are you talking about RF?
Yeah, the protocol only. Yeah. What's nice if later on, if we want to broadcast it on RF, we can just plug something and pass through the messages and it will be okay, right? But utilizing the same protocol, we can even bypass it on the internet. It's very lightweight, so it's fine, right? It doesn't really matter.
Okay. We could use that towards an app, smartphone app.
I'm sorry?
We could propagate this to a smartphone app.
Yes.
Good. But one other point, Richard, is I was not looking at this as part of the alpha build. I'm looking beyond that to where we want to go roll some out in different places. So just so there's no confusion, that this is something
this is not
that I want. I'm pushing for right away. But it's looking down the road and saying, okay, I want to go that way, and I just want to make sure people are clear on that, because that's me looking ahead because of the geographic circumstance I have. And, as far as I'm concerned, I'd love to have a network of zillions of these things all over the West Coast. And, ideally, they would be able to, in some local area, be able to coordinate, say, oh, okay, I see you, whatever. And we're going to both take a look at it. But again, that's way down the road. The first thing is to overcome the problem of places where I can locate these may not have an internet connection, and so that's the genesis of the whole thing. And like I said, the idea is to be thinking down the road, but it's not. I just want to make sure people are clear. It's not part of what we put in the alpha package to get it to get that out the door.
Yeah.
Okay.
So what I think that we need to work on that once we integrate the telescope into the system, because the telescope should receive this protocol.
Not even, I would even say before, because it gives you a heartbeat. So, for example, when I consider Mike's situation, having, let's say, a solar panel 1 kilometer up a mountain, no internet connection, but he wants to have a heartbeat of the station. Is it alive? Is everything okay? Kind of. Is there an event of a certain probability that I have to go up and look for it?
And again, the weather of it. What's the weather there? Right. That's very, very important.
Yeah, everything that fits into small packages.
Again, you're putting a station out there. You want to know what the weather is.
Especially, I want to know whether the camera view is obscured.
Oh yeah, and that kind of thing is not lost on me.
Some birds start nesting there, for example.
Yeah.
A good idea. But would that imply to have a ham radio license?
So that's something I have to look into as of yet.
Yeah. So I'm not clear on that. Now that I joined the club, I'm going to ask questions. So I have people to ask questions like this kind of stuff. Yeah.
Yeah. Well, what you might want to look into, and just so you know, my understanding is, for example, there's an experimenter class license, okay, that's pretty basic and really easy to get into and so on. And your radio station just has to once in a while jump up and say, this is experimental radio XYZ PDQ. And, it can be carried like on a sub channel or things like that. But again, that's something I got to look into a little bit. And, I haven't, because like I said, it just occurred to me here when I was talking to these folks at the observatory, and that, okay, I need an alternate because, pretty good probability that I won't be able to use their connect. Otherwise, they're all in favor of it, So, and the thing is, I think I can probably get permission to use their network, but again, that's not in place at the moment, and so on. So, anyway, so the point being, though, it also
are there license-free frequencies?
Well, they're in the amateur radio bands, so the particular frequency they're going to use, you are limited to certain chunks of the bandwidth, certain frequency bands.
APRS has its own frequency. I think it's 141 or something.
Okay.
And I need to look it up.
But that particular frequency is for that is a licensed band, right? So you need a ham radio operation.
That's my understanding.
Okay. But you were talking about APRS as a protocol. Would that not?
But again, because it's an automatic system, you might be okay at transmitting it, right?
Yeah.
But what about changing only the RF part in the device or whatever?
Yeah. Otherwise, you'll have to be, the control of the system, right? So you can really remote control and make sure that it's all working fine. And you will need to, I guess, be like an operator of it. So you might, if you become an operator of that's probably require a higher license than the technician, the one I have right now. I'll find out. I'll find out exactly.
Yeah.
Okay.
I do not see many
that's not related. That's not related for Sky 360. Okay, that's a specific solution for Mr. Santa Claus.
There you go.
I see the pro. I mean, for people, we had a lot of people coming into Discord asking, "Do you have an off-grid solution?"
So that will be an off-grid solution.
Yeah.
Yes.
Exactly.
Yeah.
And even it doesn't not
And the other
necessarily
thing,
have to be that off-grid. For example, when I look at Brad's situation, for example, Brad is not here today, but for example, he's surrounded by a lot of high trees. So he could think of, there's a little mountain up there. I can access that. I can even have power there with a solar panel, but I do not have internet. So in that case, it's very viable for a lot of people.
Yeah.
Yeah, that's very much a situation I'm in, because as soon as I put up my fisheye camera, you're going to see all the trees around me. And yeah, the skies are open to the west of me, and that's fine, but that's just a very small chunk of the sky. Like I said, I mentioned this observatory. They've got a pretty good open sky all around them, but because of their circumstance, I may not be able to use their communications network. And the other thing is, not too far from me, a very nice little hilltop over there. It's been clear cut recently, so it's not going to grow back anytime soon. And the tracker I'm building for the house here will probably wind up over there if I can get the owner's permission. But then it's got to have the solar panels, some batteries, a way to talk back to me, and so on.
Yeah,
and so essentially, I started out thinking the specific problem with this observatory, and then of course, there's no idea so great and wonderful I can't screw it up by trying to make it bigger, better, faster, longer, harder. So no problem. But I got to thinking about the general form solution for, okay, I've got trackers in different spots. I want them to talk to people, or talk back to me or to whoever they got to talk to. And I do like what he came up with, because I'm familiar with packet switching systems and different iterations of them, and it didn't even occur to me that there is in the amateur radio world there is indeed packet networks. So it's a matter of, okay, we hook up, we look like a station on them, whatever the FCC requirements are here in the U.S. and I don't know what the relevant ones would be overseas, but I would for the amateur stuff they seem to be fairly consistent.
Is there any possibility that we can use one frequency free of any license so that anyone can use globally? Is there such?
Ooh, that I don't know, but one of those things though that you run into for a lot of your global stuff, you're going to be running down the lower HF frequencies, and basically the antenna size starts getting out of hand. As a just off the top of my head remark, because as you move up in frequency, they get.
So let's say if
that or satellite, we do.
If you go for just to the horizon distance, let's say 30 kilometers.
Yeah.
What about that?
Yeah. Yeah. Again, I don't know off the top of my head.
Are we not going long wave?
Well,
I think you guys are getting lost in the weeds with something a little bit. I mean, there are already solutions out there that will allow you to connect like a TCP/IP network, line of sight with quite a distance. The idea of doing it via RF, fair enough, that's fair enough. But I really think that's going to be very much the exception. And so I just don't, so basically if your house is here and you have line of sight to the top of a hill and you want a station up there, you can get power up there. It's really easy to get that station, as part of your home network. Without going down all this other stuff.
But if the station is 1 kilometer,
okay. He's speaking not on one station but multiple. Okay.
Yeah, so I get what you guys are trying to achieve, but I'm just wondering, it's going to be quite. I think it's something to add to the feature list for down the line.
Yeah. Oh, definitely.
Well, yeah. Yeah, well, that's again. That's why I wanted to emphasize this. This is not a thing for the alpha rollout. It's a not too distant future from that point, and it's only. And like I said, I wound up on it because of my peculiar circumstance and where I'd like to get some trackers at. So, but again, I'm also want to, if I'm going to try to generate a solution like that, I want something that should work for anybody anywhere, and. But again, there's obviously, different regulatory agencies all over the world that might have to, they're going to want to, get their 2 cents worth in and things like that. The amateur bands, like I said, they seem to be globally pretty standardized, and, because they are run by their standards are set by international standards. So, but it's a matter of, okay, what does the, local, equivalent of the FCC require for them? And again, I've heard of like experimental radio stations there are also a class of licenses, and I forget what it's called. I want to say they're like station licenses, and where you see them is like, you see these people with their wonderful boats and whatnot, maritime palaces, and they got radars up there on the upper decks, and they've got marine band radios and things like that. In most cases, those boat owners are not the owner themselves is not a radio licensed person, but the license is issued essentially for in effect the boat. Because for example, in the U.S., all radars have to be licensed. And rather than an individual kind of thing, it's some sort of thing that and I don't know the details. But it amounts to, you get a license effectively for your boat, and of course you have to have FCC certified installers and all that rot, because they don't want your boat stuff when it's turned on to be interfering with anything. And so that's kind of where the genesis of me thinking about this is. And then of course, because like maritime bands are set up for maritime, obviously, we wouldn't necessarily be able to use them for here unless we want to put a remote sensing buoy out there somewhere, which I'm all for that too. But anyway, the point being that I see where there should be some fairly straightforward and, quote, famous last words, simple implementations that we can do, because basically it's more or less a point-to-point link from a tracker to either another tracker or to an internet access point or something like that.
Or from the Sentinel to the...
Yeah.
What?
So anyway, but like I said, I don't want to get too far down.
Can't you just shove a SIM card in the thing and basically set up like a mobile network?
Yeah.
Versus
that's
I mean that stuff's already readily available. I'm just trying to
Well, my situation is I just don't know all the details. Okay. And of course, the devil's always in the details. And so, like I said, I started out with.
Could we use something like Zigbee?
I'm sorry,
Zigbee.
like what?
Yeah.
Yeah, that's quite short range, though, mate. I think. To be fair.
Just a second. What's the purpose? Because we get distracted with RF.
Yeah.
When I'm distracted. When I'm proposing, right, a protocol, okay, for the which basically defines the message types, right?
Yeah.
To and from the Sentinel and the telescope, okay, where later on we can utilize that telescope, that same protocol to communicate between stations.
Yeah.
Either on the internet or via RF, doesn't really matter.
Right.
Yeah.
Okay.
Yeah.
The reason I'm suggesting this protocol is because it has 25 years of experience in the field in RF. Okay. Exactly for this purpose, right? What's the health of the stations? What's the weather in each station? That's how they know about each other, right? So think about it. RF or the amateur RF network in the end of the day will be used as the ultimate how will you call it, alert system in the case of, God forbid, the electrical shutdown, whatnot, right?
Mm-hmm.
Yeah.
You have isolated operators, right? Now, around RF specifically, there are 3 licenses. There is the technician, which is what I have, very limited, right, on broadcast. There is, after that, the general, which I think they are allowed to act as a repeaters, and the auxiliary. Our station will be like an auxiliary, right? Reporting weather, reporting objective tracks and stuff like that. I think you will need the license of at least a general, okay? But I didn't learn it, so I don't know the specific. The one above is amateur extra.
Mate, do you know if those licenses are specific to the US or like Texas, or is it worldwide? Or
so I think it's specifically
the
for the
ones
US.
No, I think this is for international.
Are those international?
Amateur
Okay.
radio.
It's the
Yeah,
same in any country.
I
Yeah,
think so. Yeah.
yeah. There's
Yeah,
some little
it's
differences, but more or less the same.
Yeah. Yeah, and
So
that was my point about the amateur bands.
I get the idea of such system, but
yeah.
it only solves the ones who make this license.
Well, it also solves the way we will construct objects and tracks. Rather us trying to figure it out, it's already defined for us.
Yes, of course. But if you go with your APRS, you say it's on the 140 megahertz, and you need to have a license, meaning this is
Again
exclusively
for the
people.
RF, not for the protocol and the messages.
Yeah, but I get the pro in having it for RF, because I
Yeah.
see hundreds of situations where this is what could be very valuable.
Yeah. Well,
The
Richard,
question
just
is, sorry,
real
wait,
quick.
let me get this question clear. Is there a possibility we can do it without a license?
No.
Different
No.
frequency. Can we use different frequencies?
You're
No,
not
no,
allowed
no.
to transmit. You're not allowed to transmit RF without a license. Period.
Yes, short wave. You can transmit
Short
only
wave, yes.
100 meters without license. 100 meters. That's it. More than 100 meters, this is illegal.
Okay, got it. Okay.
You can transmit
I didn't know that.
FM 100 meters,
Yeah.
MV, SV, whatever. No more than 100 meters. This
Okay,
is
got it. Yeah.
this is it.
Well, as I mentioned, though, one other point is that a licensed ham, and these things are essentially telemetry stations. As I understand it, a licensed ham can indeed run more than one of those under their license. So it would take on their station ID, and so I don't see that as necessarily a showstopper. I do see it as something we're going to have to look into if we want to go forward. And so I'd be happy to be looking into that a bit here, but I'm not so sure about the international side of it once you get outside the U.S. I'm just used to having to have it's just my experiences. I do things in the U.S. So, but this is one of those places. Okay, where's like Ozzy Joe when he'd be handy and things like that. But the thing is, it is worth looking into, and sound like more people than just me could use that.
Yeah.
So let me get a little, put a little energy into it here, right after Christmas or so, and see what I can find out. Rather than speculating quite as much as I'm forced to, simply in the absence of actual information.
How does a emission of RF be legally settled? Does it mean you have to have a transmitter, an electronic device with power, so that you get something on the energy on the antenna? But do you have to have ownership of that device? For example, if I have a housing that I have ownership in, and I use Ido's device because he has a license, it is his device, he turns it on, I do not even touch it, I take it, I put power on it, put it in, and it does what it does. So the possession of that device is still with Ido. I possess only the hub it is situated in. I allow Ido to be placed in my hub, kind of.
Yeah, I think you'll be legally liable though, right?
Yeah.
I think if any dodgy network stuff gets transmitted through your hub by someone, you're going to be legally liable for that hub and any implications that follow.
I was just looking for loopholes.
Well, the thing, the thing is, like I said, let me look into it, okay? Because, like I said, I'm under the impression there's various options there. It's a matter of finding one that might, be suitable and be worldwide. So let me do some looking into that. Like I said, I've got a pretty full plate until after Christmas, but it's one of those things. It's going to be a bunch of little fits and dribbles, phone calls, and emails for a bit anyway. So let me see what I can come up with on that. And I'll instead of looking at it as local to the U.S., I'll see what I can do internationally. Because The folks down at the FCC are usually not that bad to talk to as long as you're being hypothetical. Yeah, so.
For example, there's a
you can speak with any amateur ham radio person.
Yeah.
Just not me. I'm still new. But they will know the answer.
Don't worry.
I mean, yeah.
Wi-Fi with directional antennas, like Pringle cans type of antennas that can transmit up to 10, 20 kilometers. Does that count as RF and thus be licensed?
Yeah, I would think so for something that strong. But most of the ones I run into, they're basically a Yagi, and my understanding is they're only good for a couple of kilometers. On just a out of the box kind of thing. So again, that's the kind of thing I will do some looking into that. Starting after Christmas, and see what I can find out both here in the U.S. and internationally, because again that's make some phone calls, send some emails to people. Get some actual information to work with. So if that sounds like a plan, then I'll proceed accordingly.
Find out if you have a repeater in your area. If you do, the best will be to speak with the operator of that repeater, and he will tell you also which bands you can use also.
Yeah.
Because he will be on the group that are responsible for it in your area. Each area has its own kind of group that decides that.
Is this worldwide?
It won't be the FCC. It will be that repeaters and auxiliary in your area.
Yeah. Well, like I said, let me look into it and get some actual information.
I know.
We'll take it from there.
Because a stupid question. There's maritime radio, okay, and if you are skipping a boat, you have to have this license in order to make your distress call.
Right.
Yeah.
I know that in this range with these channels they use, there's also a package channel where you can digitally transfer stuff. And if you do this license, and I did it because for sailing, that's an easy one. I mean, it's a weekend test kind of, yeah. I would be able to use with my simple license to use that package channel. Would that still be a hardware solution so that what you were saying with the APRS to communicate via that specific channel of the maritime? Blah, I don't know what it's called.
Again, possibly. I do know that
the station will be considered as an auxiliary, to my understanding. If that's the case, I think it's at least the general license. It's the second one. It's not that difficult.
Well, the other.
Okay.
But look, the license is a lot about understanding these rules. Okay. And again, my understanding of the rules is of a technician, right? I don't know much about repeater, auxiliary, or anything like that. That's the next step, right? But it's a lot about rules, and it's some about electronics, right?
Mm-hmm.
The electronics, you got it covered. I think pretty good. And the third piece is kind of require and understand like RF, like the bands, which I would say this is my weak spot right now. But understanding the bands, how to calculate, meters to, how it's called, the frequencies and stuff like that. It's not too hard, but I just need to learn it. It's like two formulas.
Yeah, but well, like I said, that's something for me to look into and see what I can find out, because I know shipboard radios, they've got a slightly different, I think they have a slightly different licensing model, because essentially, but the other thing is that a lot of shipboard radios do run on what's called single sideband. And so what will happen is you'll have a data channel on one sideband and the voice channel on the other. And there might be something we could do if we said, well, gee, we're just a sideband channel at those frequencies. My only concern with them for long distance, they're basically VHF, and so they're going to be line of sight. But anyway, let me do some looking into it so we can come up with some actual information and see what we can make work.
Good idea.
Okay.
And
yeah.
Last project that I worked on at work was a IoT project. So the idea was to connect a whole lot of devices to the internet and using various network configuration. So I learned something doing that was that there were other bands operated by like 4G operators, but dedicated to IoT.
Yeah.
How do you say?
The 3Gs, the edge is free for anyone for IoT devices. So any mobile, at least in Europe, I don't know how it's in the US. In Europe, the big mobiles, they have the networks. They say everything you transmit on 3G, it's so small, they allow anything, any IoT device to go through.
I know that. Yeah, that kind of stuff. What I meant to say was that there were lots of ways to carry data to device. And then back in the day, I don't know if it still exists. There was at least where I lived, there was a parallel internet. So some guys put some Wi-Fi antenna on top of their buildings, and they run a routing protocol. And they had a few gateways to the actual internet. So they had basically a LAN with a routing protocol implemented. So I don't recall the name. I was trying to remember that, but maybe if that still exists, that also could be a solution.
Yeah.
It was open something.
Yeah, let me see what I can find out. Just because again, I was looking at I started with just a single link, and of course by the time I started thinking, well, gee, I want to do this, that, and the other, and of course it's growing quite nicely. I went from down the hill to international. So let me do some research in that, and I'm glad for the thing about IoT, because I do remember something in the back of my mind is going, yeah, there is something like that that's available, but I don't know the particulars. I haven't looked into it, and but let me do that, particularly starting after Christmas. It's kind of my busy season for some reason. I don't know.
One of them was called Narrowband IoT.
No, the question is, do you have 3G tower over there?
Right, exactly. So as long as there is no internet or mobile power.
So if you don't have that, then you won't be able to use it, right? And if you have that, then that will require a line. So you'll need to pay like a monthly payment for a line to transmit.
No. The 3G is free for IoT devices. At least in Europe. I don't know how it's in the US.
Yeah.
No, in US you will
let me see what I can find out.
How many? Like you will still need to pay per device or whatever. You probably won't need because they will need an identifier. You probably won't have a cap on how much.
Yeah, well, let me look into it and see what I can find out. Yeah. Okay, because there are some things you can do, and again, it's like I said, I'm just gonna have to do some research on it and see what I can find out, because like I said, I envision it as get it very much like an IoT type device, get it on the internet, and then from there it can go anywhere it needs to go. Now in my case, I want to come here. I got a whole bunch of stuff back here that just sits there 24 hours a day, talking to things, no problem. And so, but let me see what I can find out, and I'll start getting that information back to everybody, and we can pick it up and go from there.
Okay.
One of my fans there, I hope.
Look, Santa.
Hello.
Hello.
Santa from the north.
Oh no, I don't like doing malls. That's all right though. And anyway, so let's just leave it right here. Okay, just kind of something we want to look into. I'm sure there's a solution out there that'll be cost effective. And the other thing I'm also looking out for is I do not want some ongoing cost attached to it. In other words, you go buy the equipment, you get hooked up, talking it, and you're ready to roll. And that's one of the things I like about the amateur bands. because I know they can do radio direct to, hardline internet connectivity, that kind of thing. I know the equipment exists and so on. And like I said, the IoT thing, I'll look into that because these are fairly low bandwidth, are low. What do I want to say here? I don't want to say bandwidth. I want to say that just they don't send a lot of data at a time. They're not real data intensive. So so let me see what I can find out and figure out. And I guess for anybody, whatever ideas anybody has, feel free to DM me, and we'll take it from there.
All right. So we have 7 minutes to the clock. One person.
Yeah, I was
Okay, go ahead, Mike.
I was hoping I wanted to demo something to you guys. So it's basically the Jetson inference running the Coco planes model, trying to identify a plane flying across the sky, and just show you how quickly it runs through the frames. Yeah, so there's not.
Fire it up.
There's not. Yeah, so there's not that much. So it's basically just a command prompt. But I kind of just want to show you how quickly. So this runs. So it's, as I say, it's a Coco Planes model. It runs on the Jetson inference repository. So it uses the TechNet, and then it tries to identify planes. It's and it's using it's quite a biggish frame size. I can't remember exactly what it is, but I just kind of wanted to show you how quickly it runs through the frames. Okay.
All right.
Will you let me know when you can see my command prompt?
Yes.
Yeah, we can see.
Okay, so right, I'm just gonna hit go, and then you'll see a bunch of stuff on the terminal, and every iterate you'll see it says detected number of objects, and sometimes there's one, and that's basically when it's detected a plane. Okay. So it's going to start going now. Oh.
GStreamer.
Sorry.
The link to the file is the correct link?
Yeah, I think so. It did seem to be okay. Here we go.
Oh yeah.
So you can see it running through the frames. It's really quite quick.
So this is a video, and the size resolution is?
I don't know off the top of my head. I can, but it's quite big. It's one of your videos. I think it's one of the I'll show you the video. It's the video that we use for like Simple Tracker when the plane like flies across, but it's not like I'm not resizing the video at all, and the code is a little bit flaky, so I've got a big like try catch block around it. But the main thing I wanted to show you was so that's doing inference on the frame for a plane.
But on the full frame.
On the full frame. I mean, I think that's really, really quick. Like it's 21 milliseconds, 21, 22, 23 milliseconds.
God.
Yeah, it looks good. Yeah.
So, as I say, I just, and that's using the GPU, and you can see it's a bit flaky, but it's just the stuff that comes with the library. I just added the video in there, but the point I was trying to make is that I just think the speed of it is quite neat, and this is, as I say, it's using inference on GPU, using the TechNet and the Coco Planes model, and you can see there it's detected one object in image sort of thing, So it's all, and I've not trained that model at all. That's just the model that comes with the Coco model. So it's already able to pick up a plane, without any training from our side. Not on all the frames, but you.
Could you compare?
I mean, sure, you get the idea.
Absolutely. Could you compare the outcome of that with the simple tracker output of the same
Yeah.
video?
So basically, so this is using that's a bit more of a bigger conversation than that because so this is using something called Jetson Inference, which is a repository that's authored and maintained by a guy called Dustin Franklin, who works at NVIDIA. Now, alongside this, there's another repository, another org with a bunch of repositories called NVIDIA ISAC ROS, which seems to do a lot of the same sort of things. I was just going to try and unshare quickly and then just show you what I mean. Let me just see if I can. Okay, so hopefully that stopped sharing.
Yeah.
So I'm just going to share something else with you guys. Please browser. Okay, so this is the Jetson Inference stuff. Let me know if you can see. So this is Jetson Inference. So this is something that's maintained by this guy, and it seems to be very Jetson specific. It's been around for a bit. It does inference, and it also does some deep learning, and it works on it's very much geared towards Jetson devices, not so much GPUs. So alongside this, there's also this other project called NVIDIA ISAC ROS, which is something I've looked into as well. And there seems to be quite a bit of overlap. Oh, damn it! Do I not have the? Sorry, I thought I had it in the thingy, but yeah. So there seems to be quite a lot of overlap here with regards to stuff, like with inferencing and segmentation and object detection and all those sorts of things. And this ISAC ROS seems to be more. This is more like an NVIDIA. And like NVIDIA's idea of how you should use Jetson devices on ROS, whereas the Jetson Inference, I think, is maybe more something that this guy put together. The barrier to entry is a lot lower than the ISAC ROS, but I think from a maintenance point of view, on the Jetson Inference, it's just this one guy maintaining it, whereas on the ISAC ROS stuff, it's a lot. There are quite a few more, and so this is one of the questions. So here, for example, if we go, so there's that's the image segmentation. So if we go to, so there's object detection, you can see, and here's inference as well. Whereas this also does inference, and there's also a bunch of stuff that does object detection. So like there's also a bunch of stuff that does object detection and segmentation. So there seems to be overlap, and I'm a little bit unsure as to. So I'm trying to get clarification as to which is the better option to take. Ultimately, they both use the same thing. So ultimately, they use a DetectNet network, which then runs on TensorRT. The difference here is ISAC ROS doesn't just run on TensorRT. It interfaces with something called NVIDIA Triton, which means you can have several backends. So you can have like a PyTorch backend or a TensorFlow or TensorRT, and also it's more geared towards GPU as well. So you can do inference on like GPU and CPU, whereas the Jetson Inference is specifically just GPU based stuff. So I'm kind of still looking into it and kind of wrapping my head around it. But the point I was trying to show you guys is just how quickly it would do inference on a video, really, on a video frame, and it, yeah, it with just using a pre-trained model, it's already detecting planes and those sorts of things. So this is the route I'm pursuing. I guess is the point I'm trying to get across, really.
Mhm.
So that's the route I'm going down. Okay.
But I think the NVIDIA one should be able to achieve the same performance. That's where I get confused.
Yes. So the absolutely. So the ISEC Ross one will definitely. I would have thought would have the same performance as the Jetson Inference because they use the same kind of
Yeah.
the TechNet network and all those sorts of things. But I'm trying to understand more from a support model, and so
Yeah.
I would like to go down the ISEC Ross route because I think that's the route that NVIDIA is trying to say. If you want to do robotics using our hardware, this is what you take, and this is the route you go down. But the other one, the Jetson Inference by the guy called Dustin Franklin, the barrier to entry is a lot lower because he's already done quite a lot of the pre-work. And it might be that he's just wrapped some of the ISEC Ross stuff. I just don't know. That's sort of the stuff I'm trying to figure out. But
Got it.
the main thing I wanted to show you was that just the speed at which using the GPU it does inference on a frame and actually detects a plane using a pre-trained model. I think it's pretty neat actually. I was quite blown away when I saw how quick it does it. That's the point I'm trying to make really.
Mike,
just
I would say you have to test several videos because if you pick one where the plane is, let's say, only 500 meters above the camera, then that would be very easy for such a network to be detected within such a big 12 megapixel real estate of the frame. But take one where the plane is far away, or take some birds. You know what I mean?
Yeah, no. So I agree with you. So the thing that I was looking, yeah. So the okay. So yeah. So I agree. There's a lot of trial and error and a lot of stuff that I still need to do. The point I was just trying to show you was that using an existing pre-trained model, it's that it already detects stuff and it's quite quick. I know there's still a lot of work that needs doing, and I'm not even going to go down the route that I'm demoing here. I just thought I'd demo it to you because I just thought it was neat and cool and stuff. And it just kind of gives you a view.
Could you even twist it to? Okay, first of all, I think that within this code there's a rescaling, right? Somewhere, certainly.
Well, I don't know, and I'm not going to make that assumption until I'm sure.
Yeah.
So I don't know.
Can you check this, please?
Yeah, no, I will do, but I'm going to switch now from going down the Jetson Inference route to the ISEC Ross route, and so I'm going to dig into that a bit more because I think that's the better supported route to go down, and then I will understand all those things a lot more than I do now. I just kind of wanted to show, you know. Because ultimately that's like the first pass at inference and object detection is going to be running in unless someone joins that can do this stuff. This is the route I'm going to take to do inference and object detection using like deep learning and stuff. So I will eventually get to a better understanding of how it all works, but it just takes time. And I can't demo that to you at the moment because I tried to get that running with a video and it didn't work. And that's why I say I think the Dustin Franklin guy's done quite a bit of work already to try and make the barrier to entry lower, to try and do some of the work that I'm going to have to do using the Isaac Ross 2 stuff. So he's already done that bit. But yeah, I just wanted to show you guys. That's all.
Yeah,
That's it.
it's cool. It reminds me of a lot of discussions we had about whether we should use a tracker like you did with background subtractions or use an inference network.
I think, yeah. So my view is, I think I'm going to go down this route, and then we can do a judgment call later on.
It's certainly of value when you scout that path. Absolutely. Because at the end,
I think we can.
Sorry.
No. Oh, sorry. I interrupted.
I'm not sure who interrupted. Anyhow, okay, it's just my gut feeling. I cannot prove it. That this inference networks work good on high signal to noise ratios and bad on the other way around. But we already have you have already made that process from a frame stream to a track with cropped images, and these cropped images are the 64 by 64, as I said. Put that into an inference machine that could even run on a simple Jetson Nano, I'd say.
Yeah, no, I agree. I mean, the mechanics of how we kind of do inference is still up for debate, and
Yeah.
and the point I was just trying to get across is that it's yeah, I just thought it did inference on a frame a lot quicker than I thought it would, and I don't know if there's rescaling going on. I'm not sure, but I still think it's processing it quite quickly. And I mean, I just thought it was quite neat. So yeah, the next thing. So the next thing, so it'll produce a bunch of outputs that says this is the object it's tracking, here the bounding box, or this is the object it's it's found, here the bounding boxes and all that sort of stuff. So the one thing I want to do is to try and then capture that and plot that on the frame and kind of see confidence levels and all those sorts of things.
Yeah.
But as I say, that I want to try and do that using the Isaac stuff, not the Dustin Franklin stuff, and the models aren't available on the Isaac stuff as they are on the Dustin Franklin stuff and those sorts of things. So it's more difficult and more tricky to do. So I can't demo that to you guys, now and quickly, but I could demo the other bit. So that's all.
Sweet, perfect. Thank you, Mike. I think it's definitely a path worth exploring to go for full frame inference, if it is technically feasible. I mean, if the CPU behind it can deal with that amount of data.
Yeah, I think it's GPU. I mean, if we can get it, if we can use TensorRT and we can run it on an NVIDIA GPU, then then it should, and that Jetson device will have a GPU on it as well. So that's one of the reasons I kind of thought it's a good fit.
Yeah, let's see what the outcome is, and especially I'm interested in comparison between your tracker and the NVIDIA inference. All right.
Yeah, I think it's going to kick the tracker's backside at some, but we'll see.
We'll see. So
Yeah,
guys, it's 10 minutes over the clock. We didn't hear anything from Fabio. Fabio, you want to contribute anything for today? If not,
in fact, I have not been working a lot these past few weeks because
yeah, we heard
some of the things that happened in my life.
Yes, we heard.
But I started investigating some of this stuff so we can abstract and we don't have to work mainly with just NVIDIA boards. We can work with any AMD, NVIDIA, Intel, or even ARM CPUs that have GPUs also. That's using OpenCL and other frameworks, and not necessarily CUDA. So I've been investigating that to try to make the algorithms that will be running the background of the tractor, and maybe the tractor also working with these frameworks. so we can make them run on any hardware.
Wow, cool.
And it could be even a Raspberry Pi or anything like this. With 2 or more, we can make it run.
Okay.
And that's what we're focusing right now. So just trying to make it to make an abstract layer so we can make it work. And maybe we can find some solutions, some hardware solutions that are cheaper, and can run the necessary software on a way that we don't have to be attached to any vendor.
Bye, Yannick. All right.
Yeah. See ya.
See you. Bye.
Bye.
So to be hardware independent is wow.
Yes.
That would be great to have. Absolutely. That's my biggest concern.
Some of some of the hardware that we're using, and some of even that one that I bought, it didn't arrive yet. They have GPUs embedded, and we can use these GPUs to run software there also, but they cannot run on CUDA because CUDA is specific to NVIDIA.
Yeah.
So that's what I'm trying to achieve. I'm trying to achieve something that can make the full use of the an ARM CPU with GPU embedded.
You said you have a device with a GPU, but it's not NVIDIA and it's embedded. What can you give me in details?
Yeah, for instance, Raspberry Pi has it, and all of the ARM devices, like the Pis, like the one that I sent, the orange one, that's the new one. It has a pretty good GPU, and we have also GPUs from AMD that are embedded in some of the mini PCs, and they are pretty powerful. And then we can make use of them also. So that's what I'm trying to achieve.
All right. You mean
Instead of
stuff like Intel graphic chips on board?
Yes, Intel or even we have these mini PCs that right now we have like a ton of different devices that are like the Raspberry Pi. They are PCBs, computer on a board, and they are pretty powerful, and they have GPUs embedded.
Yeah,
and
like industrial computers.
And then we can make use of them. So that's I'm trying to see how powerful they are. So as to see how good would then be of running our software there. So we can make it cheaper and vendor independent.
Cool. Wow, I'm totally flattened by what you did and what you showed up last weeks. Thanks for having you, Fabio. Hey guys, I think we close it up for today. Any other one? Yeah, Lionel, go ahead. You're muted.
Sorry, I was just waving.
So bye guys,
Okay.
I'd say
Bye.
have a nice day.
Yeah.
See you next
Bye,
time.
guys.
Bye.
Bye. Y'all have a great one, and